In this lesson, we're going to focus on kinetic energy. By the end of this lesson, you will be able to describe what kinetic energy is, explain how energy is transferred to the kinetic store, calculate kinetic energy using the formula, and tackle high-level exam-style questions. Kinetic energy is the energy stored in moving objects. If there is movement, there is kinetic energy. If there is no movement, then there is no kinetic energy. If we look at our runner, chemical energy is being transferred to kinetic energy. So, as the chemical store decreases, the kinetic store increases. Same with our falling ball. As the gravitational potential store decreases, the kinetic store increases. So in this case, the gravitational potential energy is being transferred to kinetic energy. And for the spring, we have elastic potential being transferred to kinetic energy. The important rule here is that energy is conserved. So, if we start off with 45 joules of elastic potential energy, we're going to end up with 45 joules of kinetic energy. Kinetic energy depends on the mass and the speed. So, if we have an object with a small mass, we're going to have a low kinetic energy. If it has a large mass, at the same speed, the kinetic energy is going to be higher. If we have an object that is moving slowly, it's going to have a low kinetic energy. If we have an object of the same mass that is moving at a faster speed, it's going to have a higher kinetic energy. The equation that links kinetic energy, mass, and speed is half mv squared, where m is the mass in kilograms, v is the speed in meters per second. This equation is provided for you in the exam, so you do not need to memorize it. But it's important you know how to make a triangle from this equation. To do that, the kinetic energy goes to the top of the triangle, like so, while the 0.5 mass and the speed go to the bottom of the triangle. This makes it possible for you to rearrange the equation when needed. To solve our first example, we need to consider the variables given in the questions. For this first example, we have a car with mass 600 kilograms. It has a speed of 15 meters per second, and we're asked to calculate the kinetic energy. So this is the mass, this is the speed, and we recall our equation, which is provided on the equation sheet, to be EK equal to 0.5 multiplied by mass multiplied by V squared. So if this is V and that is M, we can just plug in those values or substitute as it's called. Mass of 600 multiplied by 15 squared. Now it's important that you do not forget the squared. A lot of students forget to square the speed, and that is where they lose marks. So I'm going to solve this first before I plug in these multiplications in these values in my calculator. So I have 0.5 multiplied by 600 multiplied by the square of 15. 15 squared is 225. And if we plug that in our calculator, we should get 67,500 joules. That will be our final answer. For the second example, we have a scooter of mass 300 kg moving at a speed of 25 meters per second. This is our mass and this is our speed. Let's recall our equation. Kinetic energy is given as 0.5 multiplied by mass multiplied by velocity squared. So plugging in our values, we have 0.5 multiplied by mass of 300 multiplied by speed of 25 meters per second squared. Okay, this gives us 0.5 multiplied by 300 multiplied by 625. If we plug that in our calculator, we're going to get 93,750 joules. For this example, you're required to find the mass of the basketball. You're given the kinetic energy as 80 joules. You're given the speed as 30 meters per second. And for a question like this, you would need to rearrange the equation, and that's where the triangle comes in. Making M the subject of the formula using the triangle, we have M equal to the kinetic energy divided by 0.5 multiplied by speed squared. Now, from the question, you're given the speed to be 30 meters per second. You're given the kinetic energy to be 80 joules. So when we plug in those values, we have 80 divided by 0.5 multiplied by 80. Sorry, 30 squared, not 80. Zero 0.5 multiplied by 30 squared. Do not forget to square the speed, as that is where most students make mistakes. So that gives us 80 divided by 0.5 multiplied by 30 squared is equal to 900. So we have 80 divided by 900 multiplied by 0.5, which is equal to 450. And that brings our final answer to 0.178 kilograms. Do not forget your units, it's very important. Now, I want you to pause the video and see if you can attempt this next question. And then you can play the video and check if your answer is correct. So for the bullet of mass 0.05 kilograms and kinetic energy of 800 joules, we're required to find the speed. For this question, we are also required to rearrange the equation, and that's where the triangle comes in once again. And for this question, this time we're going to cover the speed on the triangle. So speed square is equal to the kinetic energy divided by 0.5 multiplied by the mass. Okay, the mass is given as 0.05. The energy is given as 800 joules. If we substitute those values, V squared is going to be equal to 800 divided by 0.5 multiplied by 0.05, which is our mass. Okay, if we plug that into our calculator, we should get 800 divided by 0.5 multiplied by 0.05. Give you 0.025. So V squared will be equal to 800 divided by 0.025 is equals to 32,000. Now, to find V, we need to make this a square root. So that's 320 or 32,000, sorry. The square root of 32,000, which is equal to 178.885 meters per second. In this example, elastic potential energy is being transferred to kinetic energy. So it's important you remember the concept of conservation of energy, which means as long as there's no heat lost to the surrounding and in a closed system, the energy is conserved. What that means is if the elastic potential energy is 1 joule, that would also be equal to the kinetic energy, which is equal to 1.0 joules. We are provided with the mass of the toy car in the question, which is 0.02, and we're asked to find the maximum speed. Now, using our triangle, we can make V squared the subject of the formula. Well, we have to discover it, and then we're left with EK, kinetic energy, divided by 0.5 multiplied by the mass. In this case, our kinetic energy is 1.0 joules. Our mass is 0.020, and we just need to substitute those values into our equation. So this gives us 1 divided by 0.5 multiplied by 0.020. Plug that in your calculator, you should get 100. So V squared is equal to 100. To find V, we need to take the square root of both sides actually. In this case, we have the square root of 100, which is going to be equal to 10 meters per second. So in this question, the maximum speed is 10 meters per second. This question is quite similar to the last question. But the difference here is that we are not given the kinetic energy. We are also not provided with the elastic potential energy. However, the question tells us the extension of the spring is 0.1 and the spring constant. So for the question like this, which is a 6-mark exam style question, this is the type of a question you're going to get in an exam. You will first be required to solve for the elastic potential with this equation, which is also provided in the exam for you, so you do not need to memorize it. And then we're going to use that value to solve for the maximum speed, which is our question. So it's the same question, but this time we're provided with just the spring extension and the spring constant. Using this equation to solve for the elastic potential, our spring constant from the question is 60 Newton per meter. The extension from the question is 0.10 meter. So we can plug that into this equation and solve for the elastic potential. energy. So this will be equal to 0.5 multiplied by 60 multiplied by 0.1 squared. Now this will give us 0.3 joules. Now, if you recall the law of the conservation of energy, if the elastic potential energy is equal to 0.3 joules, and that is transferred to kinetic energy, it means that this would also be equal to our kinetic energy. Now we can use this triangle to solve for the maximum speed. In this case, v squared is going to be equal to EK divided by, just EK stands for kinetic energy, 0.5 multiplied by m, which is the mass. The mass, kinetic energy here is now 0.3 joules. Okay, the mass is 0.025 given in the question there. And now we can plug in those values to find v squared. Remember, we're looking for v squared. Eventually, we're going to solve for v. So v squared will be equal to 0.3 divided by 0.5 multiplied by 0.025. Plug that in your calculator. You should get v squared is equal to 24. Now to find v, we need to take the square root of 24. Means v is going to be square root of 24. It's going to be equal to 4.899 meters per second. And this is how you would get or solve a 6-mark question.